Perfect. Okay. Well, hello everyone. Very happy to be here. Big thanks to Tom and everybody else in the team for having me. So the BBC Tech meetup that happened in January in Manchester was actually the first one that I attended, and it feels a bit weird to be giving a talk and being on the other side here, but nonetheless, very, very excited to be here. So we're going to be looking at React Native as another sort of technology that you can use to build CTV apps and look at some of the trade-offs and the benefits of using a technology like React Native for it. So a little bit about me and where I work. My name is Mo. I head the mobile team at Theodo. I've worked on a dozen or so, probably more than a dozen mobile, web, and TV projects during my tenure here. And now I'm overseeing the higher level mobile strategy of the company, and that involves also CTVs as a subset, and we'll see why in a second. But this means that I end up working quite closely with some of the big players in the space within the React Native ecosystem. And outside of the day job, I'm an organizer of the React Native London community, where we host monthly meetups and get-togethers, which is quite a lot of fun. And Theodo is a global consultancy with over 700 people working on a bunch of different tech verticals. We've got web, data, mobile, and CTV development as well. And we've been using React Native since it came out around 2015, and then been doing a lot of the open source contributions back to it since then. And so we've seen it grow, and now we think it's actually quite a great technology to use it for TV applications en masse in production. So yeah, we'll get into it. To start off with some context around this, fragmentation in TV operating systems is a real serious problem. And if we look at the split and the spread of users mapped to the operating systems globally, there is a clear leader in Android TV. However, there is actually quite a bit of fragmentation around this. And it's far more drastic than something like the mobile world, where you really just have two big players. You've got iOS and Android. And here, instead, you're dealing with a wide range of OSs, and they each have their own set of OEMs. So Android TV is clearly a leader with about 40% market share. And then you've got Tizen WebOS at 20 and 12%, and then you kind of scale down from there. And if we try to kind of group some of these operating systems together, you've got a split between operating systems that want native applications and other OSs that used web-based technologies to create apps for. So what that ends up meaning is that you typically have a CTV team that looks a little bit something like this. So you've got a web team that's building with a web framework that will be targeting OEMs like Samsung, LG, Hisense, so Vita OS, WebOS, Tizen. And then you've got an Android team that's building for Android TV, an Apple TV team, and then also a Roku team. And so you've got these fragmentations and these verticals that are split by technology. And so it does mean that you need a lot of resources as someone who's trying to build a TV app to actually be on every single platform that you want to be on. And so looking at the technology landscape of what tools and what languages and what frameworks you need to know to be able to target each of these OSs, if we start with the web-based crowd, you can use any web framework that you like, right? You can use React, you can use Preact, which I've seen a lot in sort of the TV space. You can also use Solid, and as we saw today, just a little reflection back, you can also use Lightning.js with Solid as well, which is quite cool. So you have a lot of different sort of options, and you can pick and choose your tool chain as you wish. So web is relatively free in terms of what you want to use to build out your application. Now, on the other hand, when you go into the native side, it's a bit more limited. So if we lay these out, first of all, with tvOS, it's an Apple-based operating system, so you're going to have to use Swift or Objective-C. And then for Android TV and Fire TV, Fire OS is actually just an abstraction on top of the Android open source project. So you can basically create apps for it as if it was an Android app with some minor modifications added into it. So you can build it with Kotlin or with Java or whatever you have. And then with Roku, we've got BrightScript. Now, for those who may not be aware, Roku is actually very, very limited, and they're very proprietary, and their sort of environment in terms of development and their framework and their language is very limited. So as an example, you can't even have a JavaScript engine running in it or render HTML inside of a web browser. So that's kind of quite restricted, and it's not going to be something that you can really target with any other technologies, as far as I'm aware. I could be wrong. So let's take that out of the picture. But for when we look at tvOS, Android TV, and Fire OS, what you've got is you've reached Swift and Kotlin. And typically when you've had this dichotomy of both Swift and Kotlin and trying to target both in terms of making native apps, there have been mobile-based native technologies, cross-platform native technologies that you can use to basically target both from a single code base. And so the one that comes to mind is React Native. So React Native can be used to make apps for both Android and iOS. So it came out in 2015, was open sourced by Facebook, and is being used by them in a lot of their applications. And for those who are familiar with React, it's actually very similar. You're writing in JSX, the hooks are all the same as they are in React. It feels, as a developer, it feels very much like React, with one major difference, which is that you're using very different primitives. So instead of using DOM elements, very similar to what we saw with the universal renderer just in the talk before, you're actually using simpler primitives like views and texts. So you're using agnostic primitives that can map to the correct native components on each platform. And what that means in effect is that you're not just rendering everything inside of a web view, you're actually rendering native layer platform components and APIs on each platform. So you'll be rendering text on Android, you'd be rendering an Android.txt, and on iOS, you'd be rendering an UI text from UIKit. So it basically hooks into the native layer API for each platform. And so React Native is actually being used by like a lot of popular mobile apps. It's very stable now in the mobile ecosystem. Facebook obviously uses it, but so does Microsoft on a lot of their applications. Shopify does, and so on and so forth. So it's tried and tested in the mobile world. It had a long sort of tail of growth, and there was a lot of issues that came up. But over time, it's actually reached an incredible point of maturity now, and it's by far the most commonly used cross-platform technology on active App Store applications that you'll find both on iOS and Android. So this was a great technology to have for mobile, and pretty soon people were starting to think, well, why can't we just use the same philosophy and the same design patterns to basically target other platforms? And that's where the concept of out of tree platforms came into effect. So pretty soon, Microsoft started to use React Native for desktop applications. So they've actually released a fork of React Native for Windows and Mac OS that's kept up to date with the base version of React Native that only supports iOS and Android. And at some point, around 5-6 years ago, someone came up with the idea of using React Native for TV applications. And this was actually far simpler than the Windows and the Mac side, specifically because Android TV and tvOS actually use a lot of common APIs to their iOS and Android counterparts. So as a result, it was relatively straightforward to actually just get it up and running for TVs. And so that's where the React Native tvOS project was born. And the real goal with this was only to support the native TV platforms, so support Apple TV and Android TV, and as a result, also support Fire OS. So basically, these three operating systems that are native-based operating systems that you'll need to create native applications for, especially in the case of Apple, where you will very likely not get accepted into the App Store with an application that doesn't have a native field for Apple TVs specifically. You could suddenly create an app with native views. So you could target all three of these operating systems with a single React Native code base, which was quite cool. And so initially what that meant is you could actually target over 50% of the global CTV market share using React Native. So you could use it to target your Android TV, Fire, and tvOS users in one go, which was quite impressive. It obviously reduces a good portion of the fragmentation that you have, and you can merge some of those teams and start to target those. Now, then the question arises, what about those web-based TV operating systems, right? So for Tizen, WebOS, and some of the other ones, we've kind of grouped others here, but by and large, these other operating systems are web-based operating systems, whether they're compliant with HbbTV or they're just web-based implementations that have slight minor alterations. But a lot of these will be like your local setup boxes that you may have in your country that gets supplied by your ISP, or so on and so forth. A lot of these are really web-based technologies. So the question arises, well, what can you do about those web-based TV operating systems? Could they somehow be merged together with the team that's targeting the native platforms? And so as a result, there's always been this movement within the React Native ecosystem saying, well, we've gone from web to React Native, so we've gone from web to mobile devices, but surely since those primitives are far more agnostic in the React Native space compared to the DOM counterparts, we should be able to just go back to the web, constructing views and text back into the web equivalents in the DOM. And that's where the React Native Web project was born. And so React Native Web has been around pretty much very early on since the conception of React Native itself. which was an easy way for you to take those agnostic views and texts and convert them over to DOM elements again, almost going in a loop back to where the origins of React are. And so what that means in terms of your code base is you have your React Native codes that will go through React Native Web, which almost acts as a translation layer, and then it will render DOM elements on the other side. So using React Native Web is not just for TV applications. React Native Web is used to take React Native code bases and make web applications out of them as well. But we found that when you take React Native Web, you can actually use it to target TV applications as well. So ultimately, what that ends up meaning is that you've got React Native with a single code base that you can use to target tvOS, Android TV, and Fire TV, as well as ties in WebOS and some of the other operating systems that are web-based. And this is what we like to call, again, nod back to the previous talk as well, where we use the term universal, but this is what we really like to call the universal TV app, because it's a single TV app that can compile out and render on each of these platforms and can render natively. And we'll see some of the value of rendering natively there later on into the talk. And so ultimately what that means is basically everything bar Roku can be targeted and built for with React Native, which is really impressive, right? It's a large portion of the market share that you can basically target. Over 90% of the CTV operating systems worldwide in terms of usage could be targeted with React Native, which takes a large chunk of the users. And then Roku is obviously an outlier here, but you can target the vast majority of users that you would have. And so then the question arises, well, this is all great in theory, but who's actually using React Native for TV out in the wild and out in production? And so to start with that, the first user of it is the NFL. So the NFL has been using it for their TV apps. And so they use it extensively on, I believe, both Android and tvOS. Going to a totally opposite side of the world, in Australia, Nine Entertainment is a popular TV broadcaster, and Nine Entertainment has an on-demand platform called Nine Now, and that's also using React Native for their TV platforms, both on the web platforms and also on the native platforms. The Royal Opera House, again, staying in Australia, the Royal Opera House is also using React Native for their applications, both for iOS and Android. And then coming back closer to Europe, we've got TF1. So TF1 is the I guess the French equivalent of the BBC, since we're at the BBC Tech Meetup, but it's a public broadcaster within France who is one of the predominant broadcasters within France. And they've built their TV app with React Native. We've collaborated with them on this. And so it's really good to see this come into fruition with more and more broadcasters and more TV channels that are using React Native to target the big screen, so to speak. And so I think the best way to kind of show how this works is through a demo, which I'll now attempt to do. Live demos are usually not a good idea at the best of times, so we'll see how this goes. Hopefully everyone still has my screen, but I guess Thomas can unmute if I've suddenly disappeared for whatever reason. So I've got a sample code base here. I'm just going to reload this. So I've got a sample code base here. This is a React Native code base. So for those of you coming from the React world, you should be very familiar with this. So this is all living in this example packages. And it's got an app.psx file that defines the top level navigation. This is using a React Native library that's not incredibly important right now to look at. But really, you've got your navigation defined, and then you've got a whole set of components, some design systems, maybe some hooks, and then some pages with components that are going to be rendered on each page. And then this is all really JSX. You should be very familiar to this and feel at home if you've been in the React ecosystem. Now, I've got a web-based implementation of this application on my browser here. And so this is using React Native Web to actually export it out into a browser-friendly environment using the DOM. And then I've actually got an Apple TV simulator, and this is the exact same app running, but with Apple TV, using native views and using native functionality and native components and native APIs. And then we've got the exact same app running from Android TV as well. Now, the cool thing here is that I'm using a single dev server to basically export the JavaScript code for each of these platforms. So there's one dev server that's actually exporting the bundle, the JavaScript bundle, out to each of these platforms. And so if I make changes, I'll just reload, but if I make changes here and I say, hello, BBC Meetup, those changes are reflected across the board in all of the different implementations. So you've got it on the web, you've got it on Apple TV, and you've got it on Android TV, which is really quite cool. And it just means that really you do share a vast majority of the code base and of you share all of the business logic, but a large portion of the view logic as well. And part of the question that might arise is, well, what if I want to have some level of flexibility in terms of the files that I use for each platform? What if I want to be able to add certain things for HBB TVs or web-based TVs and have certain things for Android TVs and have certain things for Apple TVs? And this is actually very easy to do with React Native because it exposes a platform operator, which tells you at runtime what platform it is, and you can basically conditionally load whatever you want. So as you can see here on the web-based platform, what I've got is I've got arrows and mouse support. So if I click in, I can use these arrows to browse. So this would be for, let's say, your LG TVs with the mouse remote that they've got that you can use, and it's got full mouse support as well as keyboard support. So if you see here, I've got keyboard support here fully working, and this is mapping to the keys that are in my web browser. And so it's waiting for keyboard events to be triggered here. Now, if I go on to the other side, on the Apple TV, you can see that there is no mouse sort of arrows here to allow me to use my mouse. There's no support for that because we've turned that off for Apple TV because there's not a need for something like that there. But what we do have is we do have Siri mouse support. So I don't actually have a remote on hand, but this will support the Siri mouse. You're just going to have to take my word for it. But it will support you swiping across with the Siri mouse to actually go through a number of the items rather than just go by one. But I can also use the keys as a classic Apple TV remote might have with the D-pad. And now one other thing that's very interesting here is that each of these views here are native layer components and native layer views. So if you were to turn on something like VoiceOver, it would automatically have all of that information and automatically have VoiceOver and all the accessibility stuff included within it without you needing to manually go in and add that information. Because it uses all of the native layer APIs under the hood and it's rendering native views. Now, if you look at the transitions between these different pages that we've got, and all of these are just being done on the animations on the native layer. If you look at the animations here on Apple TV, they're actually using dissolve animations. So they're fading into the different pages. And if we go to the other side, you can see here that on the Android TV emulator, when you go in, there's actually a stack animation. So you can see it kind of almost pushes the page in. And that's because the navigation that's happening is all being done on the native layer. So these are native views and native pages that are being added in. And so as a result, you inherit a lot of the native layer UI and UX and the feel. Obviously, you can override them if you wish to, but in most cases, you actually don't want to do that because the more consistent UX you have with the host platform, the better experience that the users have, and the more refined it will be. So it's another cool bonus of using the native views under the hood and using the host platforms as opposed to ignoring them and just relying on the web in all times. Cool. So that's the demo there. I'll just go back into the slides. Great. So I've told you all about the greatness of React Native, some of the benefits of using it and why it's so great to target cross-platform applications with it. I do want to cover some of the challenges because there's no technology in the world that's perfect. And the two major challenges that I see, having worked with this for a few years now, is a common focus management and navigation across both web and native platforms. And then also performance on web and setup boxes, which we'll get into in a sec. So let's start with an example. I'm just going to turn off my cast. So let's start with an example. The default native layer navigation is relying on the native layer implementation of focuses, basically, and the focus management systems on each of the OSs. And so on Android TV, as an example, oftentimes when you click D-pad elements, it will look for the closest element in that direction, regardless of it not perfectly aligning. So you can see in this video, it goes left, and then it goes up to the first element on the left. So that's the behavior that the focus management within Android TV has by default. And that's just how it works on Android. Now, if you go into the tvOS space, this will only happen if the elements are perfectly aligned with one another. So if you keep clicking left on this specific screen, it will not navigate to that side menu. And the reason for that is it's not perfectly aligned. So you've got these nuances in terms of how these different platforms handle focus management on a native layer. and then you have to somehow consolidate those two together, and it's oftentimes a non-trivial problem. And what's ended up happening in the API surface of React Native for TV is that there's been a lot of solutions that have been implemented. There's TV focus guide. You can add autofocus props and trap focus props to components. There are components like touchable and pressable. Those are default React Native components that will come with focusability by default enabled. Or you can also use something imperative like next focus direction. You're not meant to understand all of this. It's just to say that there is a lot of different ways by which you can actually handle focus management within React Native on TV, and it's not consistent. And so it creates a lot of sort of mental baggage for developers to choose which approach they want to go to, and then consistently maintain that across their architecture. And the kicker here is that these don't all work with web-based TVs. So the moment that you go outside of the native world with tvOS, Android TV, and Fire OS, and you want to target an HBB TV or an HTML-based TV, a lot of these approaches just don't work. So what we had to do in our team was take a step back and almost create our own solution. So for those familiar with LRUD, we decided to go through a declarative approach that really mimics the model of React itself in terms of having a declarative tree and using that tree to understand how the spatial navigation and the focus management needs to be done. So it's called React TV Space Navigation. I've put up a QR code to the GitHub repo. This is actually not React Native specific, so that you can use this within React as well. It's purely React-based implementation, so it does not necessarily rely on having the native layer APIs. It does hook into them for those platforms, but it also runs on React, so it works on the web as well. And it's actually quite simple to use. So the first step is you just define your remote controls for each platform. So for tvOS, Android, and for web, you define what each direction maps to. So you've got an enum of directions, and you create a remote control subscriber which maps the different arrows and directions, the different arrows that can come from your device to directions, sort of geographically or Cartesian wise. And then you add window event listeners and unsubscribers as well to capture those events from the native layer or from the web and pass them to the space navigation engine that we've got. And so then it's very React-like in the way that we've set it up. It's very much like JSX, like writing any other React code. You basically wrap each page inside of a spatial navigation route, and then you define a set of nodes. And those nodes are things that the focus management engine needs to know about, that they exist. And then with each one, you can pass in an is focusable prop to it. And if that's true, then that element becomes focusable. And then you can condition the state of that depending on whether or not the focus is done. This is the base level API. There's a lot more APIs that are part of this, virtualized lists and things that are optimized for performance. But this is just the base level of how it works. There's not enough time for me to cover it in depth, but if you're interested in generally spatial navigation, some of my colleagues, Pierre and Mathieu, who are behind this library, actually did a talk in Paris at a conference just over a year ago now, where they actually talked about the inspiration. They talk about LRUD from the BBC and some of the inspiration that they took and why they went down this route, which is a great talk, and they walk you through the thinking. So if you're interested in that, just scan that QR code and save the link and watch it at a later time. So we talked about focus management and navigation across web and native setup boxes, web and native platforms. The other thing is performance on web, and specifically some lower end setup boxes and lower end devices in general. So one of the things that occurs is around bundle size. So React Native Web is an extra dependency that you add in to your React Native application. And what that ends up meaning is that you need this extra translation layer, which will get shipped in as part of your bundle, as part of your JavaScript bundle and sent to the users. Now that also adds a latency cost in the sense that it's extra data to send from a server or from a CDN to the TV. Now that's relatively negligible in the sense that it's only about 74 kilobytes when you've minified it and gzipped it, and sending that across the wire is not too heavy, even with a slow 3G connection. And in most cases, the connections at home with a TV is going to be relatively strong. So that's not really the issue. It's the extra computation that it adds and the extra script processing times, especially on these lower end devices. So you've got these added weight being put into your bundle. And on top of that, when you look at the source map for the demo React Native app that we just saw, which is the base level, demo with some of the most basic libraries that you will need inside of your React Native app, the bundle size ends up being around 1 megabyte total. So there's 1 megabyte of JavaScript that's being both shipped and run by your application on the browser. And so this is due to a little bit of legacy within the React Native ecosystem. Much of the React Native ecosystem developed around CJS, which isn't as easily tree shakeable. And so there's not been a push towards needing high web performance because all of the mobile-based platforms were the main target of React Native. And you only had to download that bundle once, and there's some bytecode optimization that happens on native platforms, which means that it doesn't actually affect the startup time of your applications to add more JavaScript in drastically. So it's just been kind of ignored. But now that React Native is actually being used more and more on web, and there's been more of a push towards it on web, there's actually a bigger push towards having full ESM support and tree shakeability for libraries within the ecosystem. And this number will only keep going down over time. And there will be lighter and lighter layers and lighter web implementations for libraries that may have a lot of native code integrated into them that you may want to tree shake for the web platforms. So it's just something to consider, that there is a relatively large bundle size that gets shipped in with your React Native app once you add some of the dependencies that you need for navigation and whatnot. Moving over to some of the setup boxes, the baseline RAM usage for an empty React Native app is around 80 megabytes. So 80 megabytes of RAM is going to be used. Now, some TV devices have a few gigabytes of RAM included within them. I think Apple TV is probably the top of that, where it's got several gigabytes of RAM. Your typical Fire TV sticks will have about 1 or 2 gigabytes of RAM within them, and they start going down as well as you go to some other OEMs. And what we've found is sometimes we've had to deal with setup boxes that have only had about 200 megabytes of RAM. So that's been incredibly difficult to deal with when you've already only got 80 for React Native, and then you're playing with about 120 megabytes of RAM for your actual application to use with some of the libraries that you may imported. So we had to spend a lot of time really optimizing memory performance. We looked at Android TV for a particular setup box, but it's something to look into. And this is a talk that another colleague of mine, Mael, did. If you're interested in that story of how we found this sort of this memory leak within our application and fixed it, and generally some of the things that we've learned around keeping memory usage low within React Native apps, that's another QR code for you to scan. So the two major challenges that we've talked about was around setup box and web-based performance, and around common focus management. All of that being said, I think there's a very bright future for React Native ahead. And there's a few reasons that I say that I think this is the right TV-based technology to invest in. Firstly, it always helps to have a big player that's encouraging people to use a technology and getting involved in the community and investing in that space. And recently, Amazon's been encouraging people to use React Native to build applications for the Fire OS ecosystem. So there's several articles that they've published. They've done several talks at conferences, predominantly React Native conferences, but also React conferences, about how you can build for the big screen using React Native and why it's a good technology to use. So with seeing that, and there's a lot of talks that you can Google around and find. These are just two examples of an article and a talk. But seeing big tech invest in a technology is typically a good sign in terms of the health of the technology and where it's going long term. So that's a good sign. But it's not only Amazon. React Native is predominantly backed by Facebook and also Microsoft. So Facebook is obviously creating React and React Native. They're the owners of the projects. But Microsoft as well has been in on the React Native ecosystem since very early on. And they've actually become one of the core contributors of it. So you can see that it's used extensively in their apps. And recently, they've actually been working on the web for React Native. So they've been working to bring React's APIs closer to React Native's APIs so that they have parity in terms of the APIs and how they behave and how the users call those APIs specifically, but also about the breadth and the availability of those APIs. And part of that effort is to make React Native Web significantly more effective. And the way that they are trying to target this is with this project called React Strict DOM. And the goal with React Strict DOM is to make the translation layer between React Native and the DOM significantly smaller. So based off of early indications, there is actually a 95% reduction in the bundle size of React Native Web by using React Strict DOM. And this is still in the beta phase. It's still being developed actively. It's experimental, but it's likely that it will come out in the next couple of years. And it's being worked on by both Meta and Microsoft together, which is a really good sign of confidence in terms of using React Native for web, which should ultimately, in the long term, also make it a much more viable option for using it on web-based TVs. and getting far, far better performance than we get today. The last thing is, again, around web performance and just performance in general. When we're looking at web performance, there are a lot of tools now to allow you to go into the depths of why certain things are being bundled. So this is a tool called Expo Atlas, and Expo Atlas actually allows you to go in and see in a very in a much more augmented way the source maps of your applications, but also then see what dependencies you're loading in that are resulting on a transitive dependency loading in, which most source maps won't do. So it's a really cool project, and the whole goal with this is, again, to tackle that issue of legacy CJS infestation, if you will call it that, of this ecosystem in React Native. And the way that they do it is by exposing which libraries will need to be migrated to ESM and support tree shakeability. When you go into the native side, one of the things that we've been working on is called Flashlight. So the whole goal with Flashlight is that you can take Android-based applications and get Lighthouse-like results and scores for each of them. So you get a very easy to understand way to run tests and run end-to-end tests almost on your applications and get performance scores out of them. And that's things like the average FPS, the CPU usage, and the RAM usage. And you can use it for any Android app. And what that means is you can also use it for Android TVs and use it for those platforms. And it's almost as simple as dropping in an APK in most cases for mobile apps, but you can run it in your own sort of environment. And so this is just a very quick demo showing it running for a TV app. And it works on TVs, and you can see the FPS and you can see the CPU usage go up and down as things are navigated. That is the QR code if you're interested in learning more about Flashlight. Just scan that and go ahead from there and look at the docs. There's a lot of interesting things if you're a mobile developer or a TV developer on native platforms. So just a quick recap on this. Firstly, React Native can be used to create native and web-based TV apps from a single code base. And you can target over 90% of the global TV users with React Native, which is really cool. It's being used by the NFL, TF1, Nine Entertainment, among many others. These are some of the public folks that have published about it and written about it. But it's being used extensively out in the open. The biggest challenges today is unified focus management around web and mobile and performance on web and setup boxes. But again, there are ways that you can tackle this. We can get sub 200 megabytes RAM, which is really, really low, and we're already getting 60 frames per second performance as it is today, and it's only on an upward trajectory as we see things like React Strict DOM come into fruition. And the future of React Native is bright. I really do believe that because of seeing big tech getting more and more invested in it. There's more performant web support coming, and we've got tools like Expo Atlas and Flashlight that can help us really nail down performance issues, and there's a rich ecosystem of toolkits around it. I'm going to leave with this. There's a resource that we've started with some of the folks at Amazon around React Native on TV. So we've created the React Native TV blog. So it's the first sort of open source knowledge base of React Native on TV. So the link is very simple. It's rntv.dev, or you could scan that QR code if you're interested in just learning more. And we're just trying to create a consolidated and single source of truth for knowledge bases for building for TV apps when it comes with React Native. Thank you very much. Those are just some QR codes to my socials in case you want to stay connected or want to ask me any questions afterwards or have a chat about React Native on TV. And yeah, that's pretty much it. I'm happy to answer any questions that anyone might have.